Okay, so Sly Gryphon, it's my name. I work for Telstra Purple. Currently work in the IoT development area, consulting, but this is not I managed to sneak in a little bit of IoT, but most of this on tracing. So logging and tracing is a bit of a weird topic, very niche sort of topic. So, but I've been interested in that for a long time because I find it really helps to be able to analyze programs correctly. Um, So why distributed tracing? So when you're debugging a program, it's invaluable to be able to set your breakpoints and so on. Once it gets into production or somewhere, you want some logs. So if it's a single process, that's relatively easy to get your web server logs or whatever and find where a problem was. But modern applications are rarely consist of one component or one process. Modern applications can be quite complex. They might have multiple processes across multiple machines, perhaps different languages, perhaps some of them as functions, uh, to try and work out the path that a particular request has taken across a whole bunch of little individual components and get a meaningful picture is quite difficult. To do it, you need some sort of correlation identifier to trace that from end to end. So I started my career in IT a long, long time ago. And even then, we were dealing with multiple components across multiple component systems. And I realized there's no kind of standard way of passing these, some sort of correlation identifier. So I had to use a custom approach. Many years later, I joined Redify, which is now Purple. There's still no such thing as a standard. Still none, still none. In mid 2020, I mean, this is something that has been missing for a long time. There was a standard published, the W3C trace context was published. By now, every single major vendor is adopting W3C trace and a project that came out of that called OpenTelemetry. Now, usually when you've got a bunch of competing standards and that, and you release another one, you just now have N+1 standards. And standards rarely get implemented quickly. I've actually been very surprised at how quickly these standards have come together and these technologies have been implemented. So quickly that if you weren't watching, you may not have noticed that this is now already very widely implemented. Almost every single major logging tracing related company is publishing articles saying that OpenTelemetry is the future of their tracing. Okay? It's not just one or two of them. It actually is everywhere. So the question then comes, I'm this .NET developer. What do you need to do to get into this new distributed tracing, correlate all the things and so on? Not a lot, because it's actually already built into the core of .NET. So W3C trace context propagation and OpenTelemetry compatibility was put into .NET 5 and is now available in .NET 6. I think they might have backported some into .NET 3 as well. And not just like Microsoft extensions or something like that. System diagnostics, a pretty core low-level library. The activity class in there has been reworked the internals, so it is an implementation of the OpenTelemetry span. So this is baked in down into the core of .NET. So anything you've written from .NET 5 or .NET 6, or if you upgrade that, you already have this built in. This is the IoT bit. Is now being built into things like Azure. So Azure now has built-in W3C trace telemetry being put out by the IoT cloud device and so on, edge devices. And they'll put it, so when you get a message from a sensor or whatever, it'll tag a trace correlation identifier that'll then start to go through, and they're pushing this through the whole Azure stack. So if you go through an application gateway or something like that, all of them will be able to correlate that tracing back into your application. I've seen it in a lot of other places in the wild as well. So Google APIs, like I was using the mapping API, and it has a trace identifier in it as well. So it's actually in a lot of places if you know what to look for. So I want to show you how easy it is and how it's already built in. So this is a very simple example. It's using kind of the out-of-the-box weather sample when you go .NET new web project. I modified it so there's two components talking to each other. So you've got a browser, you've got a front end and a back end. So you've got two server components there. They're just using a standard out-of-the-box HTTP client to make a call. And they're just using the standard logger message, which is a high-performance pattern class in Microsoft you can use for effectively making iLogger T messages. So, wake up my machine here. Yeah, that's. I thought I had increased the size. Anyway, gone small again. Oh, I think I know why. I don't know why this reset, but it did. No idea. Okay, so that's how I had it looking. Okay, so what we have here on the side here, make this big as well. Oops, not disappear it. Okay, so we have a demo service and a demo web app. Okay, and the front end is this demo web app, and it's got a weather forecast controller. And all I did was do .NET new web app, and it's created it for me. And the only changes I've made is I've commented out the usual thing that generates some random weather data, and I've put in a call to the back end and a log message so we can see some logging. And this is standard iLogger T and a standard HTTP client. I made no other changes around this application. The back end's not very interesting because it just has a log message and it's just returning the same. I kind of just passed that JSON blob back. So it's no special things in this code at all. Now, when I run this code, you might look at this. This has got no. I haven't done anything yet to show you what's in there. This is just a normal how you'd run your normal app. Okay. So there's the app running. You've got on one side you've got the web app, and the other's got the backend API. And this is what the UI looks like. And I do fetch data. This is just to show you what's happening. And you can see obviously that one end is taking the call and passing to the back end. So I see they're both doing something, right? Now, as I said, that's already doing trace correlation. It's just not being shown in the log output. So all I need to do is have a logger that is going to actually show this correlation. So all I'm doing here is I'm already outputting to console, and the default just uses the simple logger but has no options. So all I'm doing is, and it will look in your app config or app settings to see if there's any settings. If there's none, it just uses the default. So all I'm doing here is using the default settings, except I've got one extra thing which says include scopes. So I've done that for the service, and I put the same in the front end. So now I run both apps, and all looks very similar. And I'll just refresh. Oh, I also added a refresh button on this page. it's any other change I made to the standard app. So you'll now see that this has a trace ID 8BE, CBE, and you see the same trace ID over on the right-hand side. So this is built, as I say, you don't need to do anything. If you're using a modern .NET, this came in .NET 5, but the defaults were kind of using an older trace identifier that Microsoft had their own proprietary one. But from .NET 6, the default is now the W3C trace context trace identifier, and it's already there. So nothing to do. That's the best place for a programmer to be in. Okay. Any questions about that before I continue? Yes? Yes. So the W3, so for an HTTP call, it makes sense to put it in the header, right? And lots of third-party logging companies had their own way of doing it. The .NET framework from I think somewhere in 3 maybe had its own way of doing it as well, which has its own legacy one. In .NET 5, they started putting in the standardized version. And the problem with the old ones is if you had a Java app calling a .NET app, well, they're going to use different header names. So no one could ever agree on whether it could be called correlation ID or diagnostic ID or what to call it. The W3C trace context standard finally, and what format it should be. So Microsoft used to have this hierarchical one. They finally agreed on a standardized format. So that means that everyone who implements this, doesn't matter if it's a Java component calling .NET or whatever, as long as you're using the same header in the same format, it's going to work. And the header is actually trace parent, and there's no one trace state. You can go and dive into the internals of it. Okay, so that's one part of the puzzle, which is this standard, which effectively says, here's a standard header, name, and also the format of what we put in that header. And it's got some stuff to do parent-child relationships, and it's got a constant identifier that you can easily search on. And there have been attempts to do this for a long time. So in .NET 2 days, they had an activity identifier and a way to pass activities across. But that was only .NET, and it was a bit cumbersome. There wasn't an easy way to query it. It has some other stuff about version. It also includes adaptive sampling. So that means that if you're doing a million, tens of thousands of messages a second, you don't necessarily want to log or sample and analyze every single one. So there's even some, and there's no good if one tier does 1 out of 1,000, the other does 1 out of 500, but they do different messages. So part of this header also includes a identifier to say, hey, I'm tracing this and sampling this, which means the other tiers can decide to say, hey, this is probably a good one to sample as well, because then they can get an end-to-end picture. So there's a lot of good stuff in the standard. So OpenTelemetry is the next part of the puzzle. This sort of came on the back of that, using the standards, kind of a merger of 2 other projects called Open Census and Open Tracing. That's it. So what it really does is covers not just logging, which I showed you before, but a whole bunch of observability. So traces, which are around about timing and relationships between components. Metrics, which is good if you want to then correlate them to CPU or messages per second or other metrics about your application. Some of the benefits of it is automatic instrumentation. So when you add things in like a SQL or a message bus or other things or HTTP clients, you don't need to do anything. It adds the instrumentation for you. So you don't need to change your code to get this rich data coming out of it. It's open source and it's vendor neutral. It's been implemented in a large number of languages already. And because it's a standard, it means that the code in one language is now going to have the same semantics and be compatible with the logging done in other languages. And it uses that W3 trace identifier to then to correlate traces and metrics and so on across the different tiers. It's now, and this wasn't here when I started writing this presentation, it's now made it into the .NET documentation in Microsoft, right? So that'll actually go through some of the stuff that I'm covering today, how to add it to your code, to like how to configure it, and how to add your own custom sources if you want to start getting into adding your own stuff into it, which you don't have to do, but you might have specific metrics in your application that you want to add, number of sales per hour or something. So, next demonstration, how to add OpenTelemetry. Now for this, I'm going to use a bit of a more complicated application. So this still has those same two demo web app and demo service sitting there that do an HTTP call. It then has the service write into a database. It also has the front-end web app sending a message to a service bus, RabbitMQ, and then a worker app sitting there just using .NET New Worker, but then just adding a standard consumer for the message. And so we'll see how the tracing identifier will correlate the messages across all these different tiers. So again, and all this code is up on GitHub, and it's linked to from my blog as well, which was in the notes for the application. So if you missed anything, you can go there and grab it. And it's got quite a lot of detailed walkthroughs as well if you want to be able to do it from scratch. I'm using the pre-baked apps here. So again, we've got the same front end. As you can see, now this one's actually using that logger message high performance logging pattern from Microsoft. It does the same HTTP call as before. It does this, and now it does a publish endpoint. And this is using the mass transit library to write to RabbitMQ. And I haven't done anything except configure mass transit the normal way you configure it. I haven't added anything special about logging or anything. The backend app's very similar. Sorry, actually the backend app has a database in it. So here, well, that's one basic, that's not what I want. So I'm just injecting a database context here, usual entity framework code. I haven't done anything special. I've just done a normal entity framework, got a migration there to create the database. And it's just inserting a dummy bit of data into a dummy table, right? So it's not doing anything meaningful, but it's the kind of things that you'd normally do. Now, for those interested in the logger message pattern, I tend to put them in a separate log class. You can just put them in your own class. I'd highly recommend looking at this on the Microsoft website if you do any logging, rather than just doing _logger.debug or information or whatever. You use these static builders on the logger message class to pre-compile the strongly typed arguments. And that way, it actually, particularly if you're going to go into a tight loop or something like that, it actually saves it makes them a lot more performant. So do have a look at that. I also like it because it allows me to then give proper event IDs that I can surface in my logging with the name of the event and an event ID. And I tend to use event IDs very similar to you might use HTTP status codes, where I actually put a numbering system behind them so you can kind of look at the meaningful and where in the code that might be. Quite a useful system. The worker app is just a standard using that's right. Worker, background service, consumer. Is what I want. Standard consumer, just using mass transit, the iConsumer in there for the type of message. And again, it's not doing anything apart from it's got a baked-in delay so we can kind of see that in the output. Now, you've got this application. This might be an existing one. What do you need to do to add OpenTelemetry? Because I've told you it's really easy. So tick one box. You already know that it's already HTTP calls already sending the trace correlation that we need in the back end. It's already implemented in mass transit as well. So it has its own header that sends across this trace identifier, pulls it out of the context and pops it back in the other end. So that's now built into this third-party library for you. If you weren't doing that, if you're just using something like Azure Service Bus, does work kind of. Microsoft says it's automatically implemented, but that's only half true. It automatically sends it, but there's nothing on the receiving end to read it. It's only a few lines of code to add that, to read it on the receiving end, because at least it's already being sent. So you need to have that trace identifier being passed around. What we need to do is we need to add a bunch of libraries for OpenTelemetry. So I'll just open up one of these. You'll see there's a whole bunch of OpenTelemetry libraries here. Because I'm using Postgres, there's an OpenTelemetry library for Postgres. There's Instrumentation for ASP.NET Core built in. There's Instrumentation for Entity Framework. Then there's what are called exporters. Exporters are how it sends the data out. Okay. There's extensions for hosting to start it all up as well. So that's basically going to the console and adding a bunch of NuGet packages, boom, 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 boom. You obviously, each application will have a different things depending on what its requirements are. So if you don't have mass transit, you don't need the mass transit libraries and so on. Although mass transit has it built in. So different components you have might need to find the right libraries to add. And then we need to do the same thing to each component here to light it up. In your program file, I've pre-written the code just to make it easy. There's two kind of things you need to do. Okay. So the first is you need to create a resource. Now, you could probably just get away with like just that line if you wanted to. But you probably want to add some other information about what computer it's running on, what assembly, what version. So this is a resource is anything that writes telemetry or logging or tracing data. Okay, so it's a source of your data. So each one will have its own, I usually put in, this is kind of typical sort of attributes I'll put in. I'll put in the name of it, automatically put in the library, put in the machine it's running on, the OS, whether it's staging or production, version numbers, and so on. I tend to use the informational version because that way I can put a full semantic version in there, which shows if it's a particular beta release or branch it's being built on. Now, the names of the attributes here are standardized by OpenTelemetry. You can obviously add any attributes you want that are relevant to your scenario, but they've started to standardize, and some of this is still a work in progress, so that when some Java component somewhere logs the name of the machine, you're going to be logging in your .NET component the same attribute name for the name of that machine. So you can then do queries around, show me which machine has had the longest queries or something, or the longest requests or something. So you have to go in and look at all those standardized names. So that's a whole lot of boilerplate stuff I'd put in at the top of each project. And then you need to configure the different parts of OpenTelemetry. And for this demo, I'm just going to do a very basic OpenTelemetry, and I'm going to use what's exporter there's something called Jaeger, which is a tool, a tracing tool, and they will show you the difference between tracing and logging as well. So make the same changes in the next. Next step. Now I could go write this all out by hand, but I'm sure you don't want to see me making typos. And as I said, there is a full explanation in the GitHub and in my blog if you want to. I'll keep pasting stuff, I don't know. If you want to, you'll notice that the worker kind of has a slightly different pattern because it uses a different way of doing the host builder rather than the new codeless sort of way. But this will work no matter how you. That's just a styling sort of thing there. And you'll notice that I've added different ways of adding the different components. So for example, with mass transit, the previous version, I can't remember the version numbers, previous version of mass transit, because they've just released a new version, there was an extension contribution library you could add to do instrumentation of it. It's now built into the core of mass transit. So you don't need to do anything other than subscribe to mass transit as a source. Okay, so you don't actually need a third-party library. There's no library for mass transit. If you're using an older version, you need to use a library. Current version, it's built in. So this one has ASP.NET to handle the host, and client, because it's sending client requests. Again, it's got mass transit. And you'll see that first line is where I set the resource builder. And this one has, again, this is the backend service. It has the host because it's receiving messages. It's got some entity framework instrumentation, some Postgres instrumentation as well. So if I just save all that. Now note that I have not actually made any changes to the functional code in my application. So I haven't said anywhere, hey, log the SQL messages or add this information, whatever. I'm still writing log messages using the standard ilogger T, right? And I'm using the logger message pattern, but that's all still standard .NET. So this is going to start up 4 processes here. The first is just running the web app, single page app, hosting that. Then I've got the web app API, the backend service, and the worker service that's receiving the message. The other components, like the SQL, the Postgres database, RabbitMQ, and also the Jaeger that I showed you running before, they're all running in Docker. So I didn't show you that, but all that is actually in the GitHub as well. There's a Docker compose file that runs all that for you. So you just do Docker compose up, and then it runs all the dependencies. So now I've got them all running. This is running on a different port. That or was it 3? 3. Okay. Okay. So you see that they've all kind of run there in the background. I'll just shrink this a bit so you can kind of see them all running. So you can see that all the 3 components are running. It's going here to the web front end. It's going to the HTTP call to one service. It's putting in a message bus. It's the third service is picking that up and processing it. All right. Okay. So now we want to look at those results of that in Jaeger. So Jaeger, as I said, is a tracing tool. And what a tracing tool is really good for is showing you the relationships between components, and particularly investigating timing problems. Someone says, oh, the website's slow when I try to get the weather. Well, this will actually be able to show you where that slowness is. So, blow this up. So you see I've selected here the web app, which is the front end, and I've got one trace for each time that I hit that refresh button. And here's a graph that shows you that the first one, which was quite a while ago, took a long time. All the others were really quick, which is kind of what you'd expect, right? But if you saw a cluster of these going higher, like those two I did really close to each other, that one's a little bit higher. This is not a very good example because there's not a lot of data, but in a full application, you'll see the spikes and so on of where and when different requests have taken longer or shorter than needed to, or than other ones. And what I can do is I can dive into one of these requests here, and you'll see it said total spans 8. And this will show me that my web app made HTTP GET to the demo service, and then the demo service then called into a database. It also then made, from the web app, made a call, send an RabbitMQ message that got picked up by the worker and then processed. And you can see here a timing that, because there was a 200 millisecond delay here. And if I go back to the earliest one, which took a lot longer, right? So you can see here, this one took a lot longer. So you can see the startup of the first request. And interesting to note that this request actually ended after it had finished sending the message, but the actual receiving side started and is still part of that same logical operation, even though it's happened after the first one is completed. Now you can actually then dive into each of these and see, for example, whatever data happens to have been logged. So the queue name and so on. I can go in here and go in here and see there were some warnings around that. I can see the SQL query that was actually run. I didn't write anything to do any of this. I just added some libraries at the front and configured them. And I've got all this rich telemetry and information about my application. Part of that is built into things like mass transit, and part of it is by this automatic instrumentation that goes in and does introspection to have a look at and hook into the different libraries and kind of hook into what it's doing and pull out that information for you. So hopefully you've seen it's not very, not too hard to add OpenTelemetry to your project, and you'll be able to get a lot of information, particularly around for trying to then analyze issues. Now, what you will notice that all of these, a big part of this is, and here's the, what I didn't show you, here is that resource information that tells you the instance, the OS that was running on, the host name, the environment, the SDK that was used, and the version of my application. So all those information is coming through as well in terms of, maybe you could go and do your graph and you can segment it by version, and then you can see, oh, hang on, version X of the application is doing different. Or you can do it by host. You've got 10 copies running in Kubernetes, you might find 3 of them are acting weird for some reason. Now, what you'll see here is this CE or CB, that is the, oops, I was doing that. Oops. That's the trace identifier. So that's really that 32 character ID number, hex number, that has been standardized on as this is what a trace will be. The header that passes a little bit more than just that. It also passes a span, which is for parent-child relationships, a version number in case they ever do version 2 of the standard, and also a few other flags, including things like whether it should be sampled or not. But the core of it is this key value. And it's actually quite good because it's designed to, if one of those components wasn't logging, but it still passed the identifier through, you can still see the gaps in the trace because system 3 will still have that common header, even though you won't necessarily know how they're related. Okay. So, exit from that. Any kind of questions about that? I mean, I didn't show you running. Sorry.
So, about the message that is integrated into a RabbitMQ.
Yep.
Does it also have the tracing identifier part of the metadata or whatever? Because it's kind of disconnected.
Yes. So I didn't show you. I go into RabbitMQ. You can play around with it yourself. So there's actually mass transit that is specifying that. So mass transit library is doing mass transit sends messages in a specific format. And when it sends it in the format, it does have a metadata header that is for the trace identifier. As I said, there is it is injected in, if you're using any of the service bus libraries for Azure Service Bus, it is injected as metadata. The header is called diagnostic ID. They're not following the standard for the header. Don't know why. I think there was an existing one they were using. But as I said, there's no way to read it at the other end. You kind of need to have, I think if you have OpenTelemetry enabled, it will read it at the other end. But if you just have raw tracing like my first demo, it won't read it. It will send it but not read it. And there's still some parts of that that are a bit, still need some formalization of standards and stuff. So there's several different ways that Service Bus can be communicated. One is AMQP, which is a messaging standard. And there's a draft in AMQP for including the trace parent header, because obviously it's not a web call, so it's not going to be in there. It will work already for things like gRPC or anything that's using a HTTP-based headers. I even start sticking into email headers that look very similar as well, so that, you know, if any email automated system wants to pick up this trace, they can. AMQP is specified as a binary header, but Azure Service Bus doesn't support binary headers, only text ones. You might end up wanting to put it in yourself as a metadata header called trace parent, which kind of matches what it's called in the W3C web context. So I think that's probably where it will end up with, not this Microsoft specific diagnostic ID. But yes, so long as you can pass this trace identifier across, then you can then start logging and so on. So you might find that because 90% of it, like web calls, are already doing it this way, just follow that format for whatever message queuing or other mechanism you're using. Most things have a way to send some sort of metadata or extra header. Add this at one end, read it off at the other end, and then you're logging. You can correlate that in with the trace ecosystem. Okay, so the demo I just showed you then just had one exporter that exported to Jaeger, because I just wanted to show you OpenTelemetry. There's also a bunch of exporters that just go to the console as well, if you want to just play around with them in Microsoft. But what I want to talk about now is something called OTLP, or the OpenTelemetry Protocol, and a component called the OpenTelemetry Collector. So as well as this standardization of how to do the trace correlation, the semantics of what a trace is and what a span is, and what segments and how they relate, standardization of what metadata tags and what name you use for them. There's also a wire protocol called the OpenTelemetry Protocol that is used for transmitting logs, traces, and metrics from your application to send it up to any receiver that supports OTLP. And a lot of the online big tracing companies like New Relic, Honeycomb is two I've worked with, they both now support OTLP as the default for their incoming log format rather than their proprietary protocols, whatever they used before. With Azure is said they will support in Azure Monitor and App Insights, they will support OTLP at some point in the future. They don't yet. And there's a lot of people that may not support it yet. So that's where the OpenTelemetry Collector comes in. The collector is a component, a bit of middleware that you can run on. I'm running it in Docker again. That can support a number of incoming protocols, including OTLP. And then there's a bunch of plugins, exporters for the collector that will write to different locations. So I'm going to do a demo that shows it writing to Grafana Loki for logs, to Jaeger for traces. So this, instead of going direct, is going through the collector, and to Azure Monitor. And Microsoft efforts and other people's efforts have put in focus on this because it allows them to write one plugin rather than re-engineering their backend to support OTLP. While they're waiting for that, we can write an open source plugin for the collector's written in Go for one language that plugs into this. And then it wouldn't matter if it was a Java or a Rust app or whatever app sending the data to the collector. You only need to implement OTLP on that language. So without that, you'd have many-to-many complexity, right? You'd have every language having to support every single type of collector. Even if they've got the same semantics, that would be a lot of implementing. Having this converts that in the short term to a many-to-one and one-to-many problem, where each language has to implement a way to talk to the collector, and the collector needs to implement a way to talk to each endpoint. That'll probably go away once everyone supports, to some degree, once everyone supports OpenTelemetry protocol, because every language just needs to talk OpenTelemetry protocol and can talk to any logging provider. But you may still want to use a local collector because many of the third-party logging sites actually have local collectors, because that can then improve security, because you might have a whole bunch of back-end components. You want to go to one component that can forward it up. You might want to batch before you forward up. It also has a processing pipeline that can do things like some pre-filtering or other stuff. So there may still be reasons why you'd want to use a local collector. And it can talk OTLP on the way in and OTLP on the way out, but you still might want to use it. Okay, so demonstration 3, OpenTelemetry collector. Do I have anything for this? No. Okay. Probably should just shut that down, otherwise it's going to bite me again. Okay. Okay. So again, I've already got the code kind of pre-written here. What I'm going to do is I'm going to comment out this bit of code that is writing to the Jaeger exporter. And I still need to have that resource builder that I've got at the top there. But instead, you'd configure it this way. And this is going to configure, actually this is, well, down here is configuring tracing, which is the same as what I had above. And the only difference is instead of exporting to Jaeger, I export to OTLP. And configuration for my OTLP, I already had sitting in my app setting here that has the endpoint. Oops, don't want to do that. Whether it's going to batch or not, and why keeps doing that? For some reason it's got a weird pasting problem. And happens to be using gRPC variant of the protocol. So there's a bunch of other settings you can put there. So if I was going this to New Relic, I'd just have a New Relic endpoint that I would configure this to point to. Now the other bit up here that I set up is that for various reasons, well, not various reasons, OpenTelemetry, this bit is adding the overall OpenTelemetry tracing as a service. And then this is configuring it all. Because logging is already a separate part in .NET, you need a logger provider for OpenTelemetry. So that's why I kind of had to add this twice, once for the tracing and once for the logging. Again, the actual configure is fairly similar. I don't need the automatic instrumentation because I'm not doing any instrumentation here. I'm just taking whatever log messages were written and passing them on. So there's nothing extra to configure there. I use the same exporter, and this could export to other, like the OTLP console logger or something like that as well, in OTLP format. I also happen to turn on a bunch of other configuration things around, including scopes and messages and state values. Not every endpoint's necessarily going to support all them yet. One thing I will show you in the, if you look at some of these kind of hidden here, some of these are still in beta version, right? So these libraries are still in development. So if you want to add them, you may need to add pre-release to some of them. The core ones are now okay, but some of them are still being worked on. And some of that's because some of the parts of the standard are still being formalized as well around logs, for example. There's still a few bits being finalized. So I've changed it from one to the other. So I do the same in web app. And do the same in the worker. And so that's the services for the tracing. And this is why this one has the resource builder as a function, because I have to configure logging separately in here, and I don't have a nice variable I can do. But it's just the resource builder is basically just a package of data anyway. It's not really, doesn't do anything functionally. Okay. So, oops, not that. So what I'm going to run this time is this is going to have 5 screens. It's going to have the 4 screens that were there. Oh, before I run, I'll actually show you the OpenTelemetry collector configuration as well. So I'm going to run that in Docker. So I've already got Docker Compose running all these backend services. This time it's going to run directly in Docker because I want to run it as part of this, and because I want to pass in some configuration values as well. So this is the OpenTelemetry collector configuration. It's a YAML file. It says what am I going to configure to receive, and it actually does support some semi-standard protocols like Jaeger and Prometheus and other stuff around that already existed around tracing and metrics. And you can plug in. This is a plug-in architecture, so you could plug in other receivers if you really cared to. It's then got a bunch of processing pipelines. I've only got the batch processor turned on, and then there's a bunch of exporters. So Jaeger is going locally. Loki in Grafana is also going locally. Azure Monitor is going up to Azure, and there's actually scripts in the GitHub that actually will provision out into your local developer subscription the resources, the resource group with the needed app insights in Azure Monitor. But I need to put the key in. So part of what the script I'm going to run does is it goes and retrieves the key from Azure, puts in an environment variable, and then starts up the Docker container, which will inject it. Whatever your production deployment is would have some way of doing that as well. Okay. And then you configure the pipelines for traces, logs. I haven't demoed metrics in this talk. And it shows you what they're coming in on, what processes I'm going to use on them, and how I'm going to export them. So you can see that this is going to the console, which is the logging one, and Jaeger. Logs are going to Loki and Azure Monitor. So okay, it all worked. So again, it's got the single page web app host. It's got the web API. It's got the backend service, and it's got the worker over on the left here. And on the right is the OpenTelemetry collector, which I've turned on the logging output, which just outputs them to the console. Now, go into my web app and shrink that down a bit so you can kind of see everything. And refresh. And you'll see that it goes across all the different components. And you'll see the logs exporter here with the span and trace and where it's logging it to. And we're going to get cleaned. Let's do a few more for fun. Okay. So what does that look like? Well, Jaeger is going to look very, very similar. Yeah, let me go back to here. Let's find some traces. I mean, it's not really going to look any different than it did before. But you can see that this one was a few seconds ago. So these are the new traces coming in. Oh, why is it opening in a separate window? I don't know. It's weird. So there you can see, obviously there's that 200 millisecond delay in the worker, but the same sort of pattern you can see. You can see the trace up ID here, 2C08. Now, the other thing I have running is for logs. I had them going to Loki. So Loki is a backend logging system. Prometheus is kind of what Grafana is well known for metrics. And Grafana is a graphical front end for looking at that. Although in this case, we're not going to use any of the graphing function. We're just going to look at the logs themselves. So I've gone to Explorer and selected Loki as my source. Now, I'm not going to write this from memory. Going to put in a query on that. And then I've got unique labels turned on, and what I'm going to do to clean up this output is I will focus on the body. Shrink that again. So here you can see, if I open this up, 2C08 is the trace identifier, and I can actually see here 20. Probably should make this a bit bigger so you can see it a bit more. Can you kind of see that now? Hopefully. You can see the trace identifiers coming in here, and if I go down, obviously the previous one will have the trace from before. So here I can see that's the worker, then I've got the web app, then I've got the service, and these are all those tracing demo messages that I can see that that's one path from one click at the front has gone through all three tiers. So the last bit I want to show you is one of the exports I had there was Azure going up to App Insights. And the Azure Monitor workbench. So I can go into my logs here for Azure Monitor. And again, there's some examples in there how to format the output in Loki in different sort of ways. So you can see here that I've got that same 2C. Let's zoom in a little bit. You can see the same log coming in there, 2C. And again, it's got the same tracing demo, backend worker. It'll show you which component it's coming from. This is a little bit not fully implemented yet, but you can see all the components are there. Part of it is because the format of the database in App Insights and Azure Monitor was slightly different. It had this hierarchical identifier, and as the trace context standard is not hierarchical, it just has a pair, trace and span pair. So they are kind of moving towards it, but they kind of don't really fit together. So you get weird things like the wrong parent appearing and stuff. But you can either add them as your own attributes, or I presume that'll improve over time because they're looking to to standardize that. Now, some things I didn't show you. Once you've got all this information, so this is in Jaeger, you can actually then generate a graph of you and show you which components have talked to which components. So if you've got a large complex system, you can actually auto-generate what your actual architecture of an application looks like. In Azure, so I showed you the logs in Azure. Sure. The other thing is, so that's in the log analytics. And in App Insights, because it's kind of a bit of mungy where Microsoft is going with these two components, I have an application map as well. So again, this is showing me, my web app called to my worker via RabbitMQ, and my web app called to this backend service that called into a PostgreSQL. And you can see the number of requests as well for each one and what the average time was as well. So you can really start to analyzing your data, say, well, that's the leg that's taking too long, or I didn't know that component was calling that component. Why is that happening? And you can kind of really analyze your application. The other thing to look at in here is you can get a similar tracing as well as available in App Insights. I can go in here again, you see the graph of how long the different requests took overall. I can look at, I think that's the front end one. It's got 26 samples. I can pick one of those samples. And again, it'll show me that tracing graph of how long it took for the first request when it called into the, from 303 to 301, when it called to Postgres, when it's sent across RabbitMQ, the demo worker, and you can see the timeline of those components as well. And there's similar sets of graphs for your metrics, logs, and so on available in third-party tools like New Relic, Honeycomb, and all that big long list that I showed you at the beginning. So, questions? We're about to finish up. Yes?
So the map in App Insights, it was showing that if calls were successful.
Yes.
And the map in other side was showing if logs were successful. Telemetry is different. Suppose the system call is successful, but it couldn't expose or it couldn't export telemetry. Means it will show the system is breaking.
Yes, so obviously if you can't export your telemetry up to your editing provider, there'll be gaps, right? So if you know what it should look like, then you might be able to identify gaps. So yes, you could, for example, see on here that there's a component that's not connected to other components, or that there's 10 requests this way and then 10 over here, but only 3 in the middle or something. This auto-generated application map is based on the total data that's received over a certain period of time. You can configure that this is the last hour. So you show how many calls have happened in the last hour. Now, obviously, if you change your architecture, or if your architecture is business logic dependent, like, sometimes it calls A, sometimes it calls B, and you might have no calls to A in that 1 hour sample. The tracing graphing metrics you can do in Grafana and stuff like that, and other tools. It can really help you analyze in why a particular call is taking a long time. And then you can use that same trace identifier, jump into your logs and look at what the actual messages are.
Can we control the level of logs?
Yes, so this is just using normal .NET logging. So any filters you apply on .NET, whether you turn on to trace level or debug level, it hasn't changed that source of stuff.
And the same Relic can do that. I will only import this level of logging.
Yes, so you can then add filters at different levels to do that as well. And as I said, sampling. So if you're getting 10,000 requests a second, you can say sample 1%. So.
I assume you can filter sensitive data as well.
Well, that would have to be on the source as well. I don't know if there's any plugins or whatever, but yeah, you would have to do that. I think we have to finish up now. So I'll be hanging around afterwards if anyone has any questions or whatever. As I said, it's a blog. It's in the stuff, and all the code is up on GitHub if you want to have a look at that.
Thank you, Sly.